Okay, today we are going to learn 2 ways to find distance on a graph. The easiest way when you're given a graph is to use our Pythagorean theorem. So for example, on number 1, we can make a triangle out of our segment. Okay, we can make a triangle out of our segment, and we can count 1, 2, 3, 4, 5, 6. So this is 6 units long, right? 1, 2, 3, 4, 5, 6. And then we can count 1, 2, 3, 4, 5, 6, 7. And it's 7 units tall. In order to figure out our missing length here, we can use Pythagorean theorem, which again is a squared plus b squared equals c squared. So we would say 6 squared plus 7 squared equals c squared. So 36 plus 49 equals c squared. And we get 85 equals c squared. To solve, we take the square root for each side. So the square root of 85, and it rounds to about 9.22. Okay, so that is our rounded answer for C. Another way to find our distance is to use the distance formula. Our distance formula is distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? In order to use our distance formula, we have to write our coordinates of our points. So for example, in this picture, the coordinates of this point are negative 5, 5, and the coordinates of this point are 1, negative 2. So if we label our points x1, y1, x2, y2, we can calculate our distance by plugging in those values. So we would say 1 minus negative 5 squared plus negative 2 minus 5 squared, and then we follow order of operations. Order of operations says I should do what's inside the parentheses first. When I subtract a negative, that's just like adding a positive. So inside my parentheses, I get 6. And inside my parentheses here, I get negative 7. Order of operations says after I take care of my parentheses, I should take care of my exponents. One thing to be careful of on your calculator is remember that 6 squared, you can use this button right here, is 36. And negative 7 squared is 49. Okay. And then we add those two together and we get 85. And then we take the square root. So see, we get the same answer if we did Pythagorean theorem or if we use the distance formula. Because distance formula is basically a version of Pythagorean theorem. Okay. When our line is just a straight line that goes either vertical or horizontal, we can just count, right? Like the number 4. 1, 2, 3, 4, 5, 6. It's just 6 units long. There's no need to do a formula if it's just vertical or horizontal. When the line is at an angle, it's diagonal like that, we need to use one of these two formulas. Okay? When we just have points like this one, okay, when we just have points like these, so let's look at number 8. We don't have a graph, we can't make a triangle out of it. We're going to just use our formula. We're going to call this x1, y1, x2, y2, and we're going to plug everything into the formula. Okay, the formula is, on the inside, negative 1 minus 2 squared, because it's x2 minus x1. And then we add y2 minus y1 squared. Okay, you don't have to memorize this formula. It'll be on your reference sheet. We follow our order of operations. We do what's inside the parentheses first. So with -1 minus 2, that's going to give me -3. And then 4 minus -9 is going to give me 13. I do order of operations, which is exponents next. So I got 9 plus 169. I add under the radical, and then I take the square root. So if we're rounding, it's 13.34, or we can leave as a radical. Either way is fine. Okay. So those are some examples. Make sure you write this formula down. Okay, write that formula down so that you have it to do the problems.